We put the kernels of maize in a beaker, which we then place in the microwave. The oven is turned on, and after just a few seconds, the kernels start to pop. The shell of the kernels explode.
Next, we look into the temperature of oil and water when faced with the same conditions. The temperature of 1 beaker of oil and 1 beaker of water is measured before heating them for 1 minute.
After 1 minute, the temperature is measured once again.
Water has a temperature of around 46 degrees Celsius, whereas oil is much lower at 32 degrees Celsius.
Now, we want to compare the way in which biscotti and sandwich bread are warmed up.
Thanks to a thermal infrared camera, we can compare the temperature of both. The scale helps us to have an idea of the values. The hotter the temperature, the warmer the color.
Inside the test tube, there is a piece of marshmallow at the bottom and some copper sulfate at half height. We warm the tube few seconds.
In order to explain why popcorn pops, we can use a marshmallow because its shape can change easily.
Within seconds, the marshmallow expands and grows in size because of the air, which is trapped inside is heated by warm water and in turn increases the volume.
In conclusion, we can say that the popcorn pops Because the water inside becomes gas, then the pressure rises and makes the seed coat burst.
There is no vibration at the white dots and the two waves add together in the blue part, which makes a bigger amplitude.
There is half a wavelength between two identical points.
We cut up marshmallows into equally sized segments and put them inside the microwave, which no longer has the turning mechanism.
As you can see, some parts are melted and other parts aren't, so that we can measure the size of a half wavelength. Now we do the same experiment with frozen chocolate, which presents the same characteristics as marshmallow.
To conclude, if a half wavelength equals 6.5 centimeters, then a wavelength of a microwave must measure 13 centimeters.
The electromagnetic spectrum shows the scale of waves according to the different types of waves. Our measurement corresponds to one part of microwaves.